Hello and welcome everyone. September 14th, it's the Flux Open Dev Meeting. If you have agenda items, please put them on the agenda. Otherwise, it'll be a short meeting today. And I'll put the agenda link in chat for anyone who's not got it handy.
So let's also discuss about image reflector controller, the refactoring that Sun is doing. I see Sun is here. Let's discuss that as well.
So I just pulled up the maintainer's focus board and I got some kind of error. Everything seems fine, but this might be interesting.
Isn't GitHub still having issues?
I've seen a couple of weird messages from my notification controller this morning, so I think yes.
That has become a very good GitHub status check.
Yeah, you know about the outage way before it shows up on GitHub status.
Yeah, probably about 45 minutes before they actually update their status page.
So I'm not sure where to start here. Should we start with the things since the last dev meeting column? I haven't worked on any of these myself, so if anyone wants.
Yeah, so the latest Flux release comes with some improvements around those CI. Things like if you run on a multi-tenant cluster, you want to prioritize the image pool secrets of your tenants and not use the controller OEDC token. Other things that we've done is we've added finalizers to all the notification controller APIs. Not that those custom resources need any kind of finalization, but the idea is that without finalizers, we cannot report to Prometheus that custom resource was deleted. If we don't handle deletion, if we don't block the deletion, we can't signal that in the Prometheus metric. So, and this was the case before with image automation. We did the same thing here. And let's say now all the custom resources inside Flux, all of them have finalizers, even if, let's say, there is not an actual need to garbage collect or do anything when a resource is deleted. But now all the Prometheus metrics, no matter the custom resource, should present a faithful state of what's happening in the cluster. If you delete an alert, you'll see a Prometheus metric with the alert name and the fact that was deleted. So that's finally done across all controllers. And yeah, that's about it. Yeah, and we improved some fuzzing stuff. Paulo has talked about this extensively on our last call. Let's move to Hans. Yeah, go ahead, Hans. Let's talk about gating.
Yes. Okay. So to give some context and background. So essentially, I'm responsible for building out a number of clusters on-prem, and before I hand them off, I have a common stack that is installed in those clusters. So so that means, it's a perfect use case for Flux. I just say, hey, here's a repo that has my entire stack that should be on every cluster. And I can now manage the clusters over time. So because all the clusters are the same, I kind of like to have just a single branch that has all of those things. So for me to get those, new things into the branch and out to the clusters, there's really two things I would like to achieve. One, I would like to get some sort of a notification in the sort of backend alerting system that, hey, there's this change that has been applied to this cluster, so that, if there's alerts popping up in the alerting system, that, things are associated correctly, that they know that, oh, here are the latest changes applied to cluster. So that's number one. And number two, what I would like to be able to do is to roll out these changes in some sort of a controlled fashion. So sort of, I think about it similarly to how deployments roll out within a cluster, but I would like to do that between clusters. And what one could argue that you can do that via branching, right? But if you have hundreds of clusters and some changes you want to roll out, say you have cluster pairs, some things you want to roll out first on one side and then the other side of the pair, other changes you might want to roll out to both pairs at the same time. It depends on the nature of the change. So how you roll things out varies. It becomes very convoluted to try and manage that via branching, because you can't predetermine how you're going to do this. So the solution that sort of solves both these problems for me is to inject myself into the flow between the source controller and customization or whatever realizes that, and basically say, okay, so I see now there's a change coming in. So I'm going to open a change request with some external system, or I'm going to ask for permission from some external system to apply this change. And now you have one external system that knows about all the clusters and can make decisions on a case-by-case basis that, hey, we're going to roll this out. I'm going to approve cluster 1, then I'm going to approve cluster 2, 3, and stack this way, or I'm going to do 1 and 2, and then 3 and 4, or whatever the case is. But it can be done on a case-by-case basis with sort of higher level knowledge about what's the most appropriate thing to do. And of course, I can do additional things like, once I've approved a change, I can see, hey, is this cluster now starting to fire alerts like crazy? So then I assume that this is a bad change. I'm going to reject all the other ones, in which case they can start looking for new changes. So the way I've had to implement this right now seems a little bit no, it doesn't seem hacky. It is very hacky, where I kind of suspend the customization controller, and then I use I control the Git source, where I sort of pin it to commit, and then I can control the flows in this way. But like I said, it's kind of hack. No, it's extremely hacky. So, but those are my use cases in any case.
So for the first part around alerting, there is, so in the alert specification, in the spec, there is a field called summary, where you can set there the cluster name and the impact that an error would have for that particular customization or hand release. You know exactly what's in there and how bad is it, right? So even if you have hundreds of clusters, for each cluster you'll create a patch or something like that sets the summary to the cluster name, and gives some, I don't know, a link to a run book, how to fix this and so on. This is mostly part of day-to operations. But that's how you can, tell when you look at the Flux alert, hey, where did this come from?
Yeah, one clarification from my side. This, from my perspective, it's about the external alert system. So we have alert system that's sort of higher level, and yes, it gets input from Prometheus, but also there's other sources that ties everything together. So it's really in that external alert system that we have like a marker to say, hey, this cluster has got this change, and all other changes are also marked on that cluster configuration item, if you like.
And you are using the Flux Grafana integration for the markers?
No, because I'm so in my case, obviously I'm using ServiceNow, and when, like, the way I control the gate is by opening a change request. So the fact that a change request is opened on a specific cluster, that is the marker. So it's like, oh, look, here are the list of changes applied to any resource associated with cluster. And now you get all the sort of link in. So all the network equipment is tied into it, the servers, everything is tied into it, right? So yeah, the change request is the marker.
Right. So how I see things done through Git without having I mean, you do have a manual gate, but it's not a controller. It's an actual process. So instead of using branches, let's say you follow what we've been doing in our example repos, where you have this monorepo, single branch, where you have your clusters in there, and what those clusters do is they use customized overlays to deploy a thing in a particular fashion, right? With changes specified for that cluster or set of clusters, right? You can have 10 clusters which use the same customized overlay, which is called, let's say, staging or whatever. Right. So how I see this done through process and Git is, let's say you make a change to an application, you change some environment variable or whatever, or the application container image. and that change is made not on the base, not in the base directory where all the files are, which are used on all the clusters. First, you do the change in the staging overlay.
Yeah.
So you go into that overlay and say, hey, for this app, the image, I want to override the image or some environment variable with this new version. You open a pull request for that, and that's the change request for staging. Someone from your team or whatever approves that. Once that's merged, that change goes only to staging, right? Then on your staging cluster, you have a QA process, I imagine.
Yeah.
Then something or someone decides those changes are good to go. And what that means is you remove the override from the overlay and you move it to the base directly.
Yeah.
This means, okay, this change which was tested on staging, I want to promote it across the whole fleet. Now, maybe you don't want to do that and you have like 10 production clusters and you want to upgrade only 5. It's yet again a matter of, repo structure and process. You will have separate overlays, or you'll do an on the spot an overlay for only 5 clusters, and those 5 clusters could just point to the staging overlay. So you promote a change through patches until everything is patched on with that change, and only then at the end you can take the change and put it in base, and that's where that change has complete the whole process. It's done, it's verified, I can move it to base. Of course, this implies working with Git, which may not be ideal for non-technical people, or it's also hard to automate with tools, right? Because you have various issues with Git merges, conflicts, permissions, and so on. But assuming this process, which is basically the manual gating, is a pull request that someone has to approve, there is a good trace around it, who approved it, when was it merged. If you need to roll back, so you have this history, and not only the history of the actual changes, which is I bumped this image, it's also the story behind it, right? Because there on the pull request, people will comment. If you have to roll back, I'm guessing whoever will open that pull request, the rollback will document the incident. So you have the incident management through, pull requests and so on, and operational changes and incident management are somehow tied together in Git, right?
Yeah. And I do see and appreciate that flow. I guess the way I conceptualize it is that the Git side of it is really about how to release something. So, you have all the gates and all the processes to say, okay, so we feel this now is ready to be released. And once it's released, it's merged to the appropriate branch. So then where I go with that then is saying, okay, so now the Git side of it is done, and now it's about rolling out this to the entire fleet, and that's where sort of the external tool takes over.
Yeah, so what you basically want is, you don't want to do the rollout in a GitOps fashion. You don't want to deal with Git
Correct.
or anything like that. You want to drive this like CI does, right? It's imperative. You call some webhook, approve now, whatever, it goes and applies the thing.
Correct.
Now, how are you going to roll back?
Fix forward. So in other words, to roll back, you have to do a Git reverse or something like that. So git revert or fix, right? But you have to fix forward basically.
So you fix it in Git, and
Yeah.
but the gates are still closed. So
So
that
what
fix-
the way it has to work is so say you release version 2 of something. All the clusters will see version 2, pin to version 2, open a change request, right? Say cluster 1 gets approved, start deploying that, and it's determined that this went bad. That will report that back, or it does report it back saying, I couldn't successfully apply it. Or of course, it could also be that you successfully applied it, but all of a sudden, all hell breaks loose and there's tons of alerts coming. So the central system will now see that, okay, this seems like a bad fix. And it will reject all the other change requests. So all the other clusters, including the first one, will now start listening for new updates in Git. And when the Git revert comes in, well, that's a new update, right? And they will now open a change request to this new commit hash. And then that'll roll out like normal.
it will be a no op on some clusters, and on
Correct.
others it will actually do a rollout.
Correct.
Yeah, what's kind of scares me at this manual gating thing is that
Mhm.
you no longer can trust Git as being the source of truth, because it's not.
It's mhm.
That's the way your customers work. I've been a customer of ServiceNow before, and I know
Yeah.
a little bit about how the process is designed, at least in some cases. I'm sure it's different for others, but the way that we worked with ServiceNow was every change request would go to all clusters, and it started at the dev cluster where you didn't need a change request. Then there was a staging cluster where you did need a change request. You should have your change fully described, and once it's rolled out in staging and approved there, then it would get a second approval for production.
Yeah.
And so it was really one change to go to staging and production, or however many clusters it is, but separately gated.
Yeah.
Yeah, so it should be fully described by the time the change request is written, which was maddening for me as a developer, but
Yeah.
we struggled to adopt Flux.
In our case, or in this system, the platform will automate the flows of this. And by default, it is a change request, but it's a standard change request. It's automatically approved, and it's templated what it looks like, but it points to Git. So hey, all the information is in Git. It's a standard change. So it's now just a mechanism for controlling the flow, having a higher level controller outside the clusters, and having a record of, hey, something happened, and a pointer to the information of what happened. But like you said, Kingdom, it sort of it allows you to set that flow that, okay, it starts, in the lab or staging, and then it sort of rolls out in a controlled fashion.
So with the thing that I put there in that discussion around the manual gating, would that be sufficient?
Which part? Yeah. So what I'm thinking when I think about the gating, so basically, I would imagine we create a provider, right? So we define a provider, and it like you said, it's just an external API that you hit and you follow the flow. So you're saying that, hey, we need to pass this gate, and you provide some information about it. That's enough for the provider to open the change request. In our case, the change request in, against the correct configuration item, like cluster name or whatever. But essentially now you could have any central system, as long as it follows the same sort of flow. You could have any central system that sort of approves and rolls it out gradually, right?
So we had the what, the gate provider?
Yeah, so well, how can I say? So in other words, let me see so in other words, so say we say kind gate, I don't know how with the gating, like how can you well, I guess as long as you create a gate object like this, you can have a controller that manages that object, right? And open and close the gate. So that would be the provider.
Yeah, in my proposal, how this is done is through annotations.
Yeah.
You create the gate. The gate has its own automation built in. For example, automatically open the gate in work days, close the gate in weekends, or no deploy Fridays and stuff like that, where you don't need to interact with it. You only need to create it, and it should open and close itself. Another way of doing gating is through a manual process where let's say you create a gate is closed by default. That gate is referenced in a customization or a hand release, let's say, right? Then some process starts, I don't know, a Jira ticket is open or whatever happens behind the scenes, and at some point someone decides, hey, I want to start the deployment. And this can be done either with kubectl annotate that gate, and you add a specific annotation which tells the controller now the gate is opened, or you use Flux notification controller, and there is some external system that sends a post to the notification controller, and then notification controller does the annotation on its own. And this builds up on what we already have for GitHub, GitLab, Bitbucket, whatever receivers, right? You do a commit in Git, GitHub will call Flux notification controller, hey, there is a new commit, and notification controller annotates the Git repository so that source controller will not wait and pull the changes immediately. In the same thing will be, you call the notification controller from, I don't know, your Jira plugin or whatever is there. Then notification controller does the annotation on the gate, and the gate opens. Then you have a different webhook for when to close the gate. The same Jira plugin, a different button, close, and you close it. Or I don't know, you merge the request, you close the gate, you open the request, the pull request. So you can build no matter a bunch of automations without having a gate provider in any way, without Flux having to integrate with I don't know how many services. The proposal here is like extremely light and vendor neutral. I mean, it boils down to running a kubectl apply. Who does it? There are so many ways of doing it. You build your own controller, you use Flux notification controller, you have some kubectl plugin, whatever, right? another thing around having driving gates with annotations, it's also about authorization. If, let's say, this needs to be done with kubectl and you don't use Flux notification controller, only the persons that have accounts in the clusters and their account has write access to a gate, only those persons can open and close gates. So you can use Kubernetes authorization and authentication to, give access or take access away from people that are supposed to do gating things.
Yeah.
So is that what I've described here using the annotation and possibly notification controller is that flexible enough to enable you to integrate this in your pipeline?
Yeah, I believe so, right? Because it's it's very easy for me to build a controller. When I see a new change coming in, I see the details about that new commit. I'll open the change request and I control the gate that's there. It's very straightforward.
Yeah, I guess you have to have some kind of maybe naming convention or something like that. How will your controller know which gates to open based on the change request? Maybe the change request will contain the list of gates, or the change request name has to match, or some part of his name, a prefix or a suffix must match the gate name or something like that, right?
Yeah, well, currently we have this higher level object that sort of controls the Git source and the Git repository, and there we're using annotations as well. So I think, yeah, we can say, use annotations to know what we care about and provide the information that we need to send upstream, right? I think that should be fine.
Another question I have for you. You said that you have multiple clusters and you pin the commits to each cluster.
Yeah.
Does that mean you run a single Flux instance for all the clusters, or you run one Flux per cluster and you pin the Git SHA in for each cluster? How?
It's one. It's one Flux per cluster. Yeah, when we pin, essentially each application is a Git repo and one or more customization resources. So yeah, the way the flow works is that the steady state is that customization is suspended, and that's not great. And we're listening for changes, so the gate is open. So we're unpinned on the Git repo side. And then when a change is detected, we pin to that new commit, keep the customization suspended while we're waiting for approval to proceed. And once we have approval, we'll unsuspend the customization. Once that's done, we'll suspend it again and we'll unpin the Git repo. So that's sort of the flow.
So switching to gates means you have a gating controller per cluster.
Yeah.
And one or more gate objects in each cluster.
Correct.
So the top level orchestrator will have to connect to a particular cluster, open the gate there, and so on, right? Which,
yeah, it will be driven, it will still be driven from the cluster. So basically, the top level controller knows about all the clusters by definition, but obviously all the clusters doesn't know about each other. So and sort of everything is driven in a sort of a pull-based model. So the same way, like that top level controller has no access to the clusters. It can't connect to the clusters. All it knows is that there is a cluster, and it knows the identity of all the clusters, and they are responsible for connecting into that central server. They have a service account for that, and they connect up and ask for permission to do whatever. So that flow will continue, and I think it
is your controller monitoring for match then? I'm not sure I 100% understood, but I'm trying to understand whether it matters or not that the gate doesn't have any information about the change itself. So
yeah, the change itself doesn't matter, at least at this point. So what it does know is what application this is in relation to. So I, as sort of the cluster owner, I have, as I said, my stack that is deployed on all clusters. So this stack is a known application. It's defined as one application, if you like. So the change controller or that integration knows what this application is. So it will open a change request for this management stack. If there's a different Git repo to a different application, that will know what application it is. That information is injected in when the application is created. So it doesn't need to know, at least at this point, it doesn't need to know the nature of the change. It just needs to know what cluster it is. So it has to have self-awareness about the cluster, and it needs to have self-awareness about the application. So that pair of information is the only thing that matters. It would be interesting to, well, I toyed with the idea. I don't really know if it's a good idea, but I toyed with the idea of actually, when a new commit comes in, to unzip it, and you could have a file, well-known file there that has metadata about the change, right? Where you could say, hey, this is an emergency change, or this is that type of change, or whatever. But then it becomes a little bit convoluted on the Git side of things to manage that release process. But I was toying with that idea. Maybe it could be useful, but I don't have a strong use case for it yet.
I was mainly trying to think of how does the system prevent an unrelated change from being deployed, and it sounds like you have a pinning mechanism somewhere. I'm just not sure where that pin comes from. Is it the controller that you wrote, or?
Sorry, explain that a little bit.
So I've opened a change request, and I have a gate, and the gate is open, and now an unrelated change comes into the repo. How do I ensure that does not go to the cluster, since it's not part of the change request?
Yeah, exactly. So basically, the steady state is the Git repo is just listening to a branch, right? So it's not pinned to anything. And the moment it gets a new commit in, it's pinned to that commit. So it doesn't matter what comes into that branch, it's not seen or heard. And the only thing that can open the gate to start listening for new changes on the Git repo is that the change request is either approved and applied or rejected. Once it's rejected or approved, it'll open the gate and start listening for new changes.
Have you looked into Flux OCI support?
Say that again, sorry?
Have you looked into Flux OCI support that we've added recently?
I have observed that it's a thing. but I haven't looked into it.
Because with OCI, you could definitely pin things to Git without touching Git at all. So let's say you want to deploy a particular Git SHA that contains some changes to a group of clusters.
Mhm.
So instead of having a Git repository that pulls the changes from Git, you'll have an OCI repository that pulls the changes from a container registry on a particular tag, which is, let's say, staging phase 1.
Yeah.
If you want to deploy anything from Git, any kind of change to this group of clusters, you will check out a particular commit that contains changes. You'll do a Flux push of your whole Git repository content to the registry, and only then the clusters that are part of that group that are listening to that particular tag in the container registry will roll out the change.
Mm.
So how you do gating? Well, the commit is in Git, but only when your gate is open in your own system, only then you do a Flux push for that particular group. How you roll out the change to more clusters, you retag staging phase 1, you tag it as also as staging phase 2, and then that change gets propagated everywhere on staging.
Mm.
Then you do whatever you do to determine that staging is good, and how you promote all these things in production. You tag staging phase 2 as production phase 2 for phase 1, and half of your production clusters are switching to that. So having a controller for gating is no longer needed. Reaching out from the cluster to the other, to the management cluster, you can forget about that. You don't need that connectivity anymore. Everything you need to do is tag things in a container registry.
Yeah, it feels very similar to branch management, right? It's just now you deal with it via container tags, essentially, rather than branches, which has branching and managing branches can be a bit of a nightmare. The drawback of, you know, managing on both sides is that what I have to design for is a flexible estate. So clusters will come and go, they'll change, they'll scale, they'll go up and down, right? So we have this situation where the cluster estate will constantly change. By nature, we have one source of truth of what our cluster estate is, and that's CMDB. So if I will manage it also using branches or images, I'll need to have two sources of truth. I have to have CMDB, and I'll have to have, you know, that thing that drives it also have to have the cluster estate there, right? So that's one thing that really entices me to just say, hey, I have one source of truth. I have one pet that I need to feed and water. I don't have to care about anything else, but that pet I have to have, right? And someone else is caring about it. I don't have to care about it. Like that CMDB instance is there, and I can interact with it, and I sort of have guarantees or promises that it will always be there. So that's really enticing for me, you know. It's like, okay, so I can just build out logic that interacts with that, and I don't have to worry about whether I have one cluster today and 100 tomorrow, or whether it's always one, or it doesn't really matter anymore. The logic is still the same, and the source of truth is still the same.
I don't understand how OCI interferes with any of that. It's just a way of transport. So when you have the manual
Yeah.
gating
Yeah,
from that proposal, you basically hold on the artifact which Flux produces. That's it inside the cluster, which is a tar file. Instead
Yeah.
of doing that, you store the tar file in the container registry. It's the same
Yes.
stuff. It's like,
Yes.
how is that changing anything around cluster state? It's just a matter of storage.
Yes, I wasn't making a comment on the storage. I was more talking about how you drive the rollout. So as I understood it, basically to drive the rollout using container images and Git branches is pretty much the same way you need to do it, right?
No, is
Oh,
same as branches and commits,
yes.
or commits and Git tags.
Yeah, so they're pretty much the same, right? I mean,
Conceptually, yeah. You have an artifact which is attached to, which has in Flux, OCI has two metadata, two things in metadata. One is the source origin, is the Git URL and the Git SHA from which the artifact was produced. And the other part of metadata is the actual tag in the container registry that, is used for clusters to follow that particular change.
yes.
Right. So the idea is, I'm not seeing how is this different from, or worse than pinning Git shards in your Git repository.
Okay, so no, I'm not saying it's different. What I'm saying is that to control the rollout, via the source, it is very similar to me, regardless of whether you're using Git branches. Say for example, one way you could go about controlling the rollout using the source is that you create one branch per cluster. Now you have full control of, or one overlay per cluster, right? Now you have full control in terms of how things are rolled out, right? So, you have 100 clusters, you have 100 branches or 100 overlays.
Or as I said before, you have 3 overlays because you have 100 clusters, 30 are staging 1, another 30 are staging 2, another 30 are, so you don't need to create like 100 things. It's like, is the app deployed differently on all these 100 clusters? If it is, then you have to write down those differences. So it doesn't matter, no matter what you do, you still have to write them down.
Right.
Branches, overlays, patches, Helm release values, they must differ.
Well, they don't differ, but what does matter is, for example, how you want to roll it out. So for some changes, you may want to roll it out on the left side of the pair first, and then once that succeeds, you do the right side of the pair. Other changes, you might want to do a pair at the same time. Certain changes, you may need to do both sides of a pair, right? So that's why I'm sort of seeking that granularity, right? Because
OCI is the best way to do it.
Yes. So with
my opinion.
So with OCI, then you might say, okay, let's do one tag per cluster, and each cluster is then basically listening for that tag, right? Did I get that part right?
No, I would say one tag per stage.
But you still have the challenge then of saying, the change today, I want to do left first and then write in a pair, cluster pair, and to change tomorrow, I want to do pairs at a time, or another change you might want to do region at a time. So, you know, first you do US, then Europe, then, you know, Asia, whatever. Because I think if you do these groupings, the groupings are predetermined, right?
Yep. Yeah, you need to know from advance what grouping are you doing.
Yeah.
You can also change them on the fly, of course. You can commit to the Git repo where the OCI repository is for a particular set of clusters and move those to, I don't know, a tag which is based on region.
Mm.
From that moment on, the rollout will be a regional rollout. Next week, you may say, oh, no, now I want to do something else. And you change the tags again in the OCI repository definitions. So it's, I mean, I don't see how gating are any kind of different in this regard. You still have to know which gates to call to open them only for the clusters in a particular region. So that information has to be somewhere.
Yes.
And probably should be in a Git repo because you want to have like this process.
Yeah, and that's where in our case, we already have that information in CMDB, right? So that's our single source of truth of our entire estate.
Okay.
And it's very enticing to just consume that information that is already there instead of replicating it elsewhere.
Okay. Cool.
But I can definitely see the benefit of using container image over Git, that you step away from the various pains of trying to manage branches and Git histories.
From a Flux perspective, it's way better once around verification, verifying Git commits with OpenPGP is quite broken, especially GitHub, because if you merge a change, GitHub will sign off that merge with its own OpenPGP key. So that makes verification useless. Anyone can hack. If someone takes over an account, instead of committing directly to Git, it will open a pull request, then GitHub itself will sign the commit and Flux will allow it, which is, as I said, kind of useless. And that's solved on the container side because you sign each container with cosign. Then you verify it with the cosign private key, which you give to Flux, and there is no escape of that. Someone actually has to steal the private key from the Flux cluster, and if it's already on that cluster, your cluster is compromised. Doesn't matter anymore, right? So from that workflow of authorizing changes and making sure that whoever is trying to do a change on the cluster is the actual entity that's allowed to do that, using containers improves this a lot. And the second thing from Flux performance perspective is Git doing Git cloning, getting history, ignoring a bunch of files which are not YAML or whatever, just to, you clone a 1 gigabyte repo to extract 100 kilo YAMLs. It's really costly on all methods. From a Flux perspective is memory, CPU, and for a cluster perspective is outbound network, right? Which costs. It's a cost. If you download 1 gigabyte of data every minute, you are running on AWS and you reached out to GitHub, which hosts the repo, I don't know, in their own data center or Azure, you'll pay for all that traffic. So if Flux can go to ECR, which is there regional next to the cluster, there are basically zero costs for having fast loops, fast reconciles. You want to react as fast as possible, but you don't pay for all this CPU network and so on. And also about, as I said, about internal storage as well. We don't have to do checksums, git history, and so on, right? Yeah. Okay, I got your gating mechanism request. I understand now you have these high-level entity and you don't want to work with any kind of Flux sources. You want to control the rollout after Flux has acquired the artifact inside the cluster. You don't want to do it outside, neither for pull requests or container images tags. You want to do everything after the artifact is stored inside the cluster, which is a valid use case. Thank you a lot for spending the time.
Thanks for listening.
Should we move forward? Do we still have time or?
We are over time. I still have a few minutes. We have one more thing on the agenda, but I can be respectful of everybody's time. We can close the meeting if that's consensus.
Sunny, do you want to discuss the pull request?
Nothing much. There is a pull request. It introduces new API, has new sales conditions and some new features. You can look into it.
Yeah, I've been looking over it since yesterday. I'm really excited about it. I think we got some things wrong around a feature request from a user, and I've commented now. We need to move some things around. It's great that now we say in the image policy alert notification, hey, we have found a newer version, and we show the previous version and the newer version. But what users want beside this is, hey, I found this version in the YAML file, and I'm updating it with this other version, which is a total different thing from what we discover in the container registry. This is about what's actually in Git and what's the new thing that we added in Git. And I looked at image automation controller, and when you set the setter in KYAML, you basically have both. You have the old YAML node and the new YAML node that you injected. So we can definitely get both things from the setter and bubble up it into the template so people can say upgrading from this version to this version. But that's the different thing that we need to address when you do the image automation controller refactoring and not this one. So either change the issue or move that issue on image automation controller and create a new one for the policies, right? Because it's
Still
definitely
add some more details.
Yeah, we don't fix what that feature.
It was confusing. Needed more information.
Yeah.
Okay, we'll do that.
Cool.
Anything else?
Not from me. That was my.
Do we have time for another topic, or are we over time?
Do we?
Do we have time? I'm asking. It's fine if we can do it in the next meeting as well.
I have a few more minutes.
Yeah, let's go.
Yeah, I was going to start working on adding GitHub E2E tests and GitLab E2E tests. So I was wondering, so we need an account so that we can create repositories on github.com and gitlab.com and bitbucket.org. So do we use the Flux CD organization, or do we create some our own Flux CD tests organization to create those repositories?
We already have all of that.
I can't seem to find it. Could you link that to me?
There is a Flux CD testing organization on GitHub and .com and another one on GitLab.com. We use them for Go GitHub providers end-to-end testing. We also use them in Flux 2 end-to-end testing for Bootstrap that creates repos, does all things.
Cool. So I'll just add the tests with my account for now, and then once those are passing, we will switch it over to
Yeah.
this organization. Cool.
Yeah, so you create your own organizations, figure out if the testing is actually good, and at the last stage, we switch to the Flux official organizations for testing. We put there the tokens, and then we run it once over and see if everything is okay.
Cool. Sounds good.
It's very important to make sure no matter where the test crashes, we delete the repos, right? Because otherwise we'll hit all sorts of limits, and I had to delete like 100 repos back in the day on or GitHub because there was a bug in the test and so on. So I don't want to do that again.
Cool. Yeah, I'll make sure of that as well.
Okay, great.
Yeah, that's it from myself.
Any more last minute items? Going, gone. Okay. All right, that's it for today. Thanks, everyone.
Bye, everyone.
Bye.